Hello, everyone. Mic test at the same time. Yeah, my name is Dominic. I work at GitLab, but this work is in no way related to my job, so just like the GitLab part is just an asterisk. This was done just while I do bug bounty hunting on the side, and this just came to be while doing that. Presenting an ode to rabbit holes. Why is that? It's because while looking for vulnerabilities on a product, I came upon you could say an interesting research question that was certainly not going to be super promising, but also interesting in we want to satisfy your curiosity once in a while. And I feel like this curiosity is what brought many of us into the space of hacking and security. So even if there was no great outcome in the end, sometimes you just got to say, I'll go in and dive into this rabbit hole. So this is why I wrote the Decompiler, just for a small audit, and had no really other greater purpose. I'll show the background that led to the tool's creation, talk a little bit about how it works, and why I think it's worthwhile to go into these pursuits of just answering questions you have in your mind. I'll also, you get a little side of the praises for the benefits of source code auditing, because I'm a big fan of that. I can't help myself. I'll just tell you how great that is. New tool alert. YBurge, a JRuby decompiler. It reverses JRuby. It's called YBurge. See what I did there? It takes a little mix of Ruby and Java, which is what JRuby is, and removes all the bad parts and keeps only the Ruby. It's run like this. You downloaded it there. Thank you. Any questions? No, I'm just kidding. This was a TLDR for the people speedrunning the videos of the conference. What we're going to talk about, actually, what's JRuby? Because, I don't know, I feel like some people here might know what it is if you came here, but maybe you don't. And why was this tool even needed? And second point, no really why. It's just like the first why is on a technical level. The second why, just gonna dig into it, get a little philosophical, maybe even motivational, but don't worry, that won't be too long. And the how it was done, some results, and answer questions, there are any. So we got the what, the why, the how. The who is me, the when is now. So we can do the rest. JRuby, what is this? It's Ruby running on JVM. You might be asking, why would anyone do that? It's high performance. I put quotes because if you're a C programmer, you're going to laugh at the performance. But Ruby is not very performant, and JRuby performs more. So that's got that going for it. It has easy integration for Java, and some people are into that. It has better garbage collection, at least when it was created. Probably not true anymore, but this is a fairly old thing. And I think it's just a sneaky way to use Rails in a Java enterprise environment. I have no sources on this, but I feel like it was created by people who really wanted to have a Rails app in a big corp environment that required Java, and they're like, I'll show you how I'll have my Rails anyway. JRuby applications come in 3 formats: white horse, brown horse, and dark horse. The first one is just standard Ruby. If you've never written or even seen Ruby before, looks like this. This code just defines a class named greeter, and this class says hello name. So it really only defines it, doesn't even execute the code. And that's what it is. So you don't even, what I'm getting to here is that it just takes standard Ruby and it can execute it. Obviously, there's no reverse engineering needed here, so we can swiftly move along. Another second type of JRuby application is the one it's a Java class with embedded JRuby code. As with all Java, it's extremely verbose. I'd like to remind you, this was my original code. Now we have this, and we can't read it, but if you zoom in on one interesting part, you actually have the source code embedded into it. So you just use your favorite Java reversing tool, JD GUI or JD CLI, And at the top, you have the original code. You wouldn't even have the source code comments if there were any in the code. So as far as reverse engineering, well, you're done. Congratulations. That was easy. But there's a third format. It's Java with that. Let's do another little zoom again. There's every single JRuby file that's compiled under this format is exactly the same. Like the code we see at the bottom, the main and the load IR class will be copy pasted in every single class. And you have this big binary blob at the top. At first, I mean, what's in there? We see like greeter.rb, so it preserves the file name. That's fun. We see greeter, we see say hello. There's some of the strings from the original code are there. So this prompt, when you approach this and you have no idea what it is, this prompts some questions. Is this just the source code compressed? Is this the source code encrypted? Is it compressed and encrypted? Is it something else entirely? Also, the questions you're asking, am I really going to spend weeks going to build something to figure that out? Well, if I'm here, you know what I answer to that. So I built a decompiler for it. I'd like to state that I have no idea what I'm doing with that. I was just curious. I've never done any reverse engineering. Well, I was for a long time a developer. This seemed like something someone who likes to code could do. So I jumped into that. But another question, why though? Like, why would I even do that? There are many reasons not to do it, actually. JRuby is pretty niche. Like, I could build this whole thing and nobody will use it. So you have that voice telling you, move on to another project. And yeah, so even if someone, like one person might use it, myself, I came across one JRuby application while doing bug bounty hunting. I could move on to another target that doesn't use this. That would be so much more simple. If I'm really looking for bounties, well, I could get more by spending time elsewhere. And just black box testing the application without figuring out how to reverse it would probably give me a better return on my time investment. And any money I make in the end after having made this decompiler will pale in comparison to the large amounts of time I'm going to invest here. Even if I do find some bugs, probably my hourly rate, I never calculated it because it's scary. And even if I want to build tools, I could contribute to another project that's probably more worthwhile. But on the other hand, there are many reasons to do it. Heading into uncharted territory is pretty exciting. Even if nobody cares, nobody has looked into that. Maybe nobody cares because nobody has looked into it. So you could be the first person and then get 20 people interested into it. So that feels like exploring new territories back when there are places on Earth that were not mapped. The first person to get there. Because believe me, I Googled. I didn't want to do this. Ooh, sorry about the puff. Learning about random things can be fun. I just learned a ton of things while doing that. And research a lot. Learned about, like if you scope it, learning about JRuby is not the most useful thing in the world, but a lot of concepts you learn while building something here to decompile, while reversing a technology, while reading into open source projects. At some point, I even contributed back to the project. All of those things made me learn things that are good takeaways with this. So this is something that makes it worthwhile. Stepping out of your comfort zone, we hear this all the time, but it's actually fun. And I was really curious, and just giving into that is pretty fun. Just doing something for fun. You know, a lot of people in our industry, and I think this is especially true of the people who do bug bounty hunting, like you figure out, hey, I could do something else that makes me money instead, but doing things for fun doesn't hurt. I don't expect to make money when I go on a hike. I don't expect money when I play video games. I could do something related to hacking, and I don't expect any money in return. That's actually, it's good. It's good once in a while. It removes the pressure as well. And creating tools for hackers so the next person doesn't have to go through this is also a worthwhile endeavor. I'd like, actually, if someone ever uses that, I'll be pretty hyped. Even one person uses it. That would be pretty exciting just to know that, what I just spoke about, it was useful to someone. And ever so slightly improving the JRuby environment as a whole and giving back to the original community that prompted this work is also fun. And I'm not going to click on it, but I open an issue and open a PR, fix the bug in JRuby that I encountered while reversing it. Now this profits everyone. So that's actually many reasons you can find to go and dig into those rabbit holes. And last but not least, well, if I find vulnerabilities, that's going to be fun because that was the original reason for doing this. And it would be a pretty good bonus. So the back in the slide where we saw the big binary blob, wondering what that was, it was called script IR, and there was a function called load IR. I saw IR everywhere. I had no clue what that was. So the quest to understand what all of this is and to actually reverse the thing starts by figuring out what it is. And, well, they have a wiki page, and it says it's internal representation. So that's first clue. That's pretty good. I'm not going to read this to you. This is boring, but I have a link if you're especially interested. But basically, the gist of it is that JRuby reads the Ruby and then transfers it to its internal representation before Java-izing it. So this is what we were seeing in that binary blob over there. And we really wanted to figure out what it was. And while looking more in the source code, looking what it had around IR, now that I had this keyword, internal representation, everything, I found something called IR dumper, which dumps IR, as you might have figured out. I would suppose the JRuby devs use this for debugging. Frankly, I don't know, but I found that extremely useful. There's a screenshot we'll zoom in of what IR dumped IR looks like. As you would expect from some sort of intermediate language, it is extremely verbose. You lose all the control flow statements, like if, while, all of that is gone. We have jumps now. But it's sort of readable, and we're actually going to look at it a little bit. So we're back with the code we had at the top. If we dump the IR, we have this thing here. First few lines is like some sort of prelude, as if you were looking at a assembly function. And then we have actually a line num, like it preserves the line numbers, which gives you a little, maybe there's original source code in here, really, because why else it would care about the line numbers. And then we see def class with the name greeter, which I would assume is used to illustrate that I'm defining a class. So we move on, read the rest. The class body, another some sort of prelude again, and then we see it defines an instance method, say hello, looks strangely like the code I had originally. Still looking at this for the first time, like, oh, wow, there might be source code that's recoverable here. And then you have another part that is the say hello function. Once again, a whole bunch of stuff that's really more for the computer than for a human. But you do see the part where it creates a string, hello, concatenates with name, and then under it calls the function called puts, which is like the print of Ruby. So my original code was 5 lines. And I got this whole thing. But from this, I thought to myself, if you hide the code there, reading this, I could make a mental image of the original code that generated this. So maybe there's a way to automate this, create a tool that reads this IR and creates the code. So that's really when I first saw the IR, I thought, this might be possible. This is going to be a lot longer than I thought. Yeah, but let's do it. But yeah, looking at the IR, are we finished? Did we reverse the application? I mean, sort of. But the 5 lines of meaningless code generated 40 lines of IR. This isn't really going to scale for a real application that's thousands, maybe more, millions of lines of code. And now if there's anyone here who reverses assembly, they're just laughing at me because they have to read that sort of stuff. But I really did not want to do this. Because I don't have real code, there's no IDE, no editor support. I really do like to click and say, show me usages of this function. I'd like to be able to do that. Also, when auditing source code, this was Ruby-ish. I have grep and semgrep patterns that I've developed over the years to analyze Ruby code bases. I'd like to be able to use them in this, so recovering original source code will actually allow me to do that. So when we look there, yeah, as I was mentioning, there was a lot of information, even line numbers, so really that just told me there's a way to decompile this and not only like disassembly. It's not assembly, but you get what I mean. The step one to get to the decompiler was to figure out how JRuby itself loads the binary internal intermediate representation blob that we saw earlier. If we see how JRuby does it, kind of gives you a lot of clues on how you have to do it yourself when you're building a tool to do that. The good news is that just like with the IR dumper earlier, the JRuby code base does the heavy lifting and has actually a public class that you call, it loads the thing and returns you the list of all the instructions. Basically every single line of the IR we saw earlier, it gives you each single line in an array that you can process yourself. So that was very nice of them. And really, as I mentioned, I was a developer calling into other people's code, totally right up my alley. So that really, once more, another clue that proved that this would be more than possible. At this point, it was just a matter of doing it. So really, the initial code was just, there's a compiled script loader. It's as if they did it for me, actually. And to this point, I was still kind of afraid of investing time in discovering that the JRuby tool itself already includes something that does what I'm trying to do, but it doesn't. So yeah, the JRuby interpreter is basically trying to do the same thing as I am. It breaks apart the IR, it executes it. So let's look at how JRuby does it. In the code base, you can see there's an IR folder with a bunch of stuff, Tailflow instructions, interpreter, blah, 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 blah. A lot of those things are not super relevant to us. But when we break apart the IR, it contained instructions and operands. If you dig into that, there are instructions that are define class method, define instance, define meta class, etc., etc. This is really each expression, each block that you can find in a Ruby piece of code. So those are the things we're going to work with to generate the code. And there are operands, like this frozen strings, hash, exceptions, integers, etc. Those are all things that make sense, at least in a Ruby world. And when we run this code, when we run the load script from file, basically it gives us a list of each of these. It says the first, we have a define class instruction. It contains all of these. So this ended up being just going through the list of each instruction operands that the script loader gives us. And it's possible to just, with a 1,000 lines long Ruby file, iterate over each of those and say, if I'm seeing a define class instruction, then I just output the string define class with the name of the class. And doing all of that, I ended up with the tool. Actually, I had an initial slide that said, I'm not going to do a demo because really, how exciting can it be to see a CLI tool work? But I figured there's still some payoff to that. So we're going to look at it. I'm going to try to transfer. Oh, it works. Yay. Oh, I have the screen there. So just going to make some tests. Can we see? Oh, can we see? Okay, we can't see anything. Zoom. So just gonna do just because we want to see, if true, you don't need to do that in real life. We just want to see code being output. Hello, hack in the box. So when we compile this code, there's a JRuby compiler, compiles this test code, this test class. it is done. That was exciting, wasn't it? And we have the class file. And then we have our little tool, JRuby, then yBurge. We want to decompile this class, output it, and this one as Ruby. And then it crashes because demo gods. I actually did. This is, wow, that's awesome. I did it just before, actually. No, what happened? What did I do? I swear it works. I've decompiled some pretty complicated code before. Let's just, if we do a super simple file, I was in the previous talk, and I did it while I was watching. Oops. Lag. Let's just do a one line. I swear it works on more complicated than that, but for today, give me a break. JRuby compiler test. Oops. Test.rb. Then do this. I didn't like my if true, I guess. That was weird. But yeah, so the out is what we'd expect. We lose Ruby doesn't require the parentheses when you call a function, so the output always has them. I gotta try to do better than that. Like if we have a x equals true, and if it doesn't work, I'm just gonna admit defeat to the demo gods, but let's compile it again. JRuby-C. Good. The tool doesn't like bad code. That's actually what's happening. Yeah, so it does like if else. There was no else. It just, it's extra verbose. But it works and then the code is good, basically. So that's why if you have crashes, it's because the original code was not good. I'm just kidding. So I'm going to close this one. Yay. All right. That's funny because in my notes when I intended not to have a demo, I said I'm going to skip the demo to avoid the demo god's wrath. That was missed. So now we have a tool. What can we do with it? Well, we can unmask security through obscurity. We can find vulnerabilities that would have required a lot of effort to find through black box testing. But now that we have the source code, I know, like if you have hard-coded keys, if you're using something that you assume hides your code, you're going to have a bad surprise when someone gets your code, basically. So I'm going to have a few examples from an unnamed JRuby Ruby on Rails application. A JRuby Ruby on Rails? A JRuby on Rails? I don't know how the people call it, but let's go with JRuby on Rails. One of the things, especially when you decompile an application, especially a web application, if you're black box testing, you're going to have to, if there's no Swagger endpoint or whatever that tells you what are all the API calls you can do, well, you're going to have to fuzz to figure out what all the APIs do. When you can reverse, you get all the roots definitions. That's actually pretty fun. It helps you test every single part of the application, unmask a lot of things that probably have vulnerabilities, but the API is not even documented. In this case here, one of the fun things was that one of the undocumented APIs listed the API keys for every single user. Was that supposed to be there? Was that a backdoor? Who knows? But now it's fixed, and really, I don't think I would have fuzzed my way to find that. So that was one of the ways just recovering the source code for the application really helped in finding things that would have remained obscure. Little mass assignment issue, and if you don't know what a mass assignment is, it's just when you allow the user to set more properties than you would when the user finds a way to set more properties than you expect them to. So if the UI only has, like you set username and email, but if hard code's in their JSON role and as admin and it works, this is a mass assignment vulnerability. Well, here, when creating API keys again, when you're an admin, you could create an API key that had this property access all engines, and engines make sense in this application. Well, this is something that I would like to have as a low privilege user. The UI hit it, but when running some semgrep patterns that I have, I just realized that the access all engine setting that was there, there's actually no code that checks if the person setting the parameter is an admin. They did part of the job correctly, because in Ruby on Rails, like, you have this permit function. So if I was going to set, like I mentioned, role, oh, there's engine role, so that my engine names, but yeah, if I was to set a role property and there's no role explicitly set in the permit, it would fail. However, they failed to check the permissions of the people calling this. So what this does is that a low privilege user can just call this the limited access key, say access all engines, and now you have access to every single thing. Could you find that by yourself? Maybe, but if you don't have an admin account, do you even know that access all engines parameter exists? That's unlikely. So that was another finding that was made possible with the compiler. And something I really wanted to talk about, because nobody talks about that, is all the non-vulnerabilities I found. Why would I talk about this? Vulnerability reports obviously get all the attention, but knowing for sure that something is invulnerable is awesome. Like, when you're doing a pen test or any security assessment, you have an XML input. Like, maybe there's XXE, and you just spend the time, try a bunch of payloads, you try a bunch of stuff, and you always have this thing. Is there one thing I did not try that would have worked, that would have triggered the vulnerability? And you kind of have this nagging in your head. When you have the source code, you could actually check if they coded it properly. You can know for sure this is not exploitable. So you save so much time, you save so many what-ifs in your mind, you save so many waking up in the middle of the night, like, I could have exploited this. You don't have that anymore. You can decompile and figure out that actually it was not vulnerable at all. No, if you had tried quadruple encoding with UTF-16, it would not have worked. So this is actually one of the biggest benefits I find. Like, the vulnerabilities, many of them, you could have found in black box, but knowing for sure something is not exploitable, awesome. This is a not common injection. There was this endpoint that I felt like it shelled out, it did something, some of the error message felt like I had a common injection, but maybe this doesn't say anything if you're not a Ruby programmer, but this is actually the correct way to shell out. Congrats, developers, you did it well, and I'm not going to spend like 3 days trying to bypass the thing. It works. They did it correctly. I think this is great. I can move on. I save so much time. I'm getting back the time I spent creating the tool slowly. Not XXE. I'm not going to show the code. It was way too long, but basically, XXE happens when you have some settings in your XML parser that allow you to load external entities, that allow, basically there's a list of settings you really want to be off. Well, you have the code, you look at how it was configured, vulnerable configuration is not there. Amazing, moving on, especially with XML. Like, it changes if it's running on Linux or Windows, and Java usually loans only the first line, so you try to bypass with so much time saved, you just know it's not vulnerable. So that's one of the huge perks of this. But now that I spent all this time doing this, I'd like to, get some more value out of this. What are the ways we could do this? Well, one of these is hack more things. I did this for one target and I expected I would never use it again. But there are actually other companies that use this, so might as well look into their code, and maybe the hard-coded credentials example I mentioned earlier, there was not actually those in the app I was looking at, but maybe someone out there is using JRuby compilation as some sort of secrecy mechanism for things they're hiding in their source code. So let's just go outside and expose those secrets. But it's JRuby though, so even if I want to hack more things, who even uses JRuby? So that's the challenge here, is to find more people using it. There's a few ways to do that though. So asking on social media, I did post, hey, folks, do you know someone who uses JRuby out there? And I had one person reach out to me with an application that I'm going to look at, so that was exciting, dare I say. Good trick, someone told me. You can find job ads looking for JRuby developers. Now you know they use JRuby internally. So of course, this is Decompiler. You need the actual binary to do that. But if they have any self-hosted application, you can just download it, decompile it, and surprise them with vulnerability reports. I hope they have a security email or a bug bounty program. And just another way of finding companies that use JRuby, putting the tool out there. And like my initial idea that nobody would care for this, nobody would use it. Well, I had a vague mention somewhere on my GitLab profile that I was working on this. There was no code, nothing. And I've had 2 people contact me saying, hey, do you have this? I'm looking at JRuby application. That would be awesome. So there are more of us out there. I'm not alone. So actually, well, I told them this is about to be released, so I'm looking forward to the things they find. And I really hope they find great bugs with it, because that would be pretty exciting. And what's next for the tool itself? Well, first, as a software developer, just possibly going to give in to the urge to rewrite the whole thing and make it clean. The code base right now is not my best work, but it works. I was going for MVC. It gave me the code I was looking for. I worked on it, found vulnerabilities. I was happy. Putting it out there and having possibly people use it is something that is a motivation to do it cleanly now. Break the dependency on JRuby itself. So I mentioned earlier the whole binary blob. It's deserialized by calling JRuby, and it's basically returning me the thing. But if they remove this code, if they change anything, if they watch this talk and they're like, I actually don't want you to do that, well, surely there's a way to parse the thing myself and extract the data and just stop dependent on JRuby, and it will allow me to rewrite the tool in something else in Ruby, which also be another great plus. So this is one of the things that's coming up. Community contributions, maybe? The eyes are looking at you, people, if you're interested, if you use it. And hack more things, as I mentioned earlier. And that's going to be, that part is coming up for sure. So it should be at the top of the list, really. But also I like building stuff. So, always, I don't know if there are any tool builders in here, but there's that struggle of building tools is fun. Hacking is fun, but which one is the most? So you just end up building tools all the time and not hacking anything. Some takeaways from this project as well. Why I would recommend diving into similar rabbit holes and spending so much time doing this. It can be more useful than we think. As I mentioned, people reached out to me and they actually wanted that. We don't have the whole picture either. I built this for one specific project. There might be someone out there who just saw that and was like, actually I can use it for something else I've never even thought about. So that I look forward to hearing about that. Building a tool is fun and fulfilling, actually. Like, you have a challenge, you have a task, you're like, I want to see through this mystery. So you build a magic robot that does it for you, and when you run the tool and it doesn't crash, so satisfying. So that's another good reason to do that. Learning is fun. I think most people in this field are kind of information sponges that like to learn about new things. So that was actually a pretty fun process. Felt like back when my hobby wasn't my job, just doing something purely for fun. And you might end up talking about it in Thailand, which is also a great plus. It was my first time here and loved the food, the beaches, and everything. So yeah, I am already on the final slide. I figured this is the last talk of the day, and there are drinks already out there. So that's you're probably looking forward to have your beer in hand instead of listening to me. A few links if you care to download the tool, to follow me, read the blog. There should be a blog post with way more details than you care for about this tool at some point. A bunch of thank yous, the JRuby project in their open source community just for creating this tool and making so many resources available. If JRuby itself was not open source, probably would have never gotten to that. Hack in the Box for having me. Valentine for reviewing the CFP that got me here, because if I had written it completely myself, probably would have said no. The Houston, which is a cool hacker I know, who gave me the idea to look through job ads to find other companies use JRuby. And the Carbon for the pretty code screenshots. And all of you for watching. Thank you.